we're going to take a look at quite a common type of question that pops up here. So this is when you've got an earlier part of a question, particularly about integrals, where you'll be told something along the lines of, between 1 and a, the area under a curve is such. And in that question, they tell us that the area under this curve is 16. And then what we need to do in the other parts here is we have to kind of relate that to the situation that's being given to us. Okay, so let's have a go at that, the first one. So imagine I went in and I tried to do this. So first bit I'm going to do is I'm going to say this is the same as root 5 root x dx. And I'm going to sort of, try and, this is a, isn't it? Let me just make that a little bit clearer in my working out that this is the unknown a. Okay, so I've said that it's root 5 of what there before, and I might try to sort of do something, if that's x to the half, I might try and do something like this. Yeah. But that would be a mistake. Okay, so why would that be a mistake? Well, it would be a mistake because what I'm trying to do down here is just not the right way to go about it. If I go back to my diagram up here, well, what it's telling me is it's telling me that the integral from a to 1 of root x is already 16. So I need to be wary of answering the question again, and I need to just spot what's going on here. So instead of me doing all of this, what I'm supposed to do is I'm supposed to notice that this is root 5, but all of this business here is just 16. And the reason why it's 16 is because I've been told that earlier on in the question. Okay, so you have to be slightly wary of over-answering questions. And I need instead to just say that this is 16 root 5 units squared. Okay, so the reason that this would sort of be a mistake is just the way that we're going about it. And you'd often spot this because this might sort of say 1 mark next to it or 2 marks or something. So let's have a go at one more that sort of does something similar. So I had the integral of root x before, and this time I seem to have the integral of root x again. So what's going on here? Well, what's going on is that I've been given slightly more than is actually in the integral that I had at the start. We were doing 1 to a, and this one is 0 to a, so this is a little bit more. So one way that we could answer this, and it depends slightly on the nature of the question, is we could instead say that from a to 0 is the same as a to 1 plus 1 to 0 of the same thing. And one advantage of doing that is I know that integrating from a to 1 is 16, because that's what we did in the earlier question. So it's 16. Well, what about this other bit here? Well, here I might actually have to do some integration. So this is root x, isn't it? Root x dx. So for this one over here, I would actually need to do that bit of integration. So that's x to the half, so it becomes x to the 3 over 2, so it becomes 2/3 x to the 3 over 2. And then I would actually use my limits there of 1 and 0. Okay, and if I do that on this particular question, if I put 1 in, I will just get the outcome of 1. Okay, and then if I put the 0 in, I will just get a 0. So what you'll end up with is a 16 plus a 1, which will be 17 units squared. So again, we're not supposed to sort of reinvent the wheel. We're supposed to use the fact that we already know something that's related to it. Okay, so pause the video and have a quick go at this one here for yourself. Slightly different part B to follow as well, but try and use the fact that the information at the top here should be related to the integrals in part B. So I'm going to assume now that you've had a go at that. So the first thing here is the way that the 9 is written is we are just going to remove the 9 outside. So it becomes as follows. It is between B and 1. And if we check the question, that's what these limits are as well. So this just turns into 9 times 6. And the reason for that is because we were given the integral here in the first part. So it's just 54 units squared. Next, we've got x to the third. Well, we look at the limits. So what's happening in this one? So in this one, again, we would split this up. So we would say it's b to 1, which we already know the answer of, and then it's 1 to 0. So this was, it wasn't 54, sorry, it was 6. That was 6 units there. And from 1 to 0, well, this will actually just end up being 1 for a similar reason to the previous one. Okay, this one here is going to just become 3/4 x to the 4/3. And when you put 1 and 0 into that one, oh no, sorry, it's going to have a 3/4, isn't it? So it's going to have a 3/4 take away a 0. So it's going to be 6 and 3/4, for example, for the final answer. Let's just check, did we make any mistakes with that when we did this one here? Yes, we did actually, didn't we? So that was going to be a 2/3 as well. So 16 and 2/3 because of that 2/3 there at the start. Okay, let's try this other question here now at the bottom then to try something a little bit different. So it says, show that B is 3 to the power of something. So let's rub this bit off here and let's have a go. So where does B come up? B comes up in the integral. I think I need to use the one that's sort of the most complete piece of information. So let's go back to this starting integral from b to 1 of, what was it, of x to the third. So I know that this is equal to 6. So if we integrate, when we integrated, we had 3/4, didn't we? So we had 3/4 x to the 4/3. Evaluated at b and 1 was equal to 6. So if I do 3/4 of b to the 4/3 minus, if I use 1, I will get just 3/4 equals 6. Let's go for exact form. So let's write this instead as 24/6. No, 24/4, sorry. Let's add this to both sides and we would get 3/4 equals 27/4 with b to the 4/3. Yep. Let's multiply by 4 on both sides to get rid of that one there. Let's divide by 3. So we have b to the 4/3 now equals just 9. And what's the goal? Show that it can be written as 3 to the power of. Okay, so let's use to the power of 3/4 on both sides. That's a nice trick to use. So b equals 9 to the power of 3/4. And 9 itself, we're going to rewrite 9 itself as 3 squared. So b equals 3 squared to the 3/4. So b equals, what's that to finish off with? That's 6/4, isn't it? Or 3/2. Okay, so m equals 3/2 to finish. So something a little bit different to finish off with there. But The main idea of this video really is just sort of looking out. They often appear as sort of two parts afterwards. That's the inspiration. And the idea is it should be something that's related to what you have done earlier. Let me know if you spotted the mistake too.